Hey guys, it's Mr. Lawler here, and I am going to be talking to you about exam skills today, specifically focusing on variables. What we want to do is identify variables from graphs and tables, from text, from descriptions, and to be able to suggest control variables for investigations. So if you're ready, then let's go. Now, why do we actually do this? Why do we teach you exam skills? Especially since you don't have exams this year. Well, these variables and understanding variables is going to help you all throughout the rest of your career, whether you're doing an apprenticeship or whether you're doing A-levels next year, whatever it is that you're doing. It really, really helps to understand these variables so that you can be a knowledgeable citizen. When you see something like this newspaper clipping in the news, you'll understand what it's all about. So it says students are baffled after business studies question appears on biology exam paper. But if you look deeper on that, you'll see it's pretty much just a common sense question. It says, what's an independent company? Well, an independent company in this case is really obvious from the context that it's common sense. If you want to develop a drug, you can't test it yourself. You have to have other people testing it for you. And so in that sense, independent just means the same thing it would in any normal context. Okay? So understanding variables is really going to help you to do well in the rest of your life. So focusing on the three key variables that we categorize in science are the independent variable, the dependent variable, and the control variable. So this is a little bit of a refresher for some of you, but we're going to hopefully take it deeper so that you can understand in a new way, maybe somehow that you didn't understand it before, about how tables and information is structured on graphs and stuff like that. So this is going to help you. Okay, so recap. The IV, the independent variable, is the one that gets changed in the experiment. The dependent variable is the one that's being measured. Now, just because you measure out 50 milliliters of water and add that in, that's not what we mean by measured. What we mean by measured here is the result of your experiment. Okay, so you do this and you see how much this happens and you measure how much that happened. Okay, so that's your dependent variable. The control variables need to be kept the same. Don't just say use the same thermometer. It needs to be something about the conditions that could otherwise obviously change the outcome of your practical. So those things need to be controlled. All right. So these are all examples from real exam papers. Okay, so you might get some information in a text. So this is the pondweed experiment. This is a biology example. Okay, students set up 6 boiling tubes, leave it for 2 days, leave it with an indicator. Indicator is pink at the start of the investigation. So the independent variable is the one that is being changed. So they're investigating the effect of pond organisms on the amount of carbon dioxide in their surroundings. Okay, the dependent variable, in this case, the amount of carbon dioxide, that is the one that is being measured. Okay, so we've got things like water snails, we've got pondweed, and that's being changed to see if that makes a difference. Okay, and a control variable in this case is leaving it for 2 days. Now I can also see that they changed something else in this practical. They changed the level of light in there. So sometimes there's more than one investigation going on at the same time. It would need to be very, very clear how those were different in order to make that separate, to make your results valid, your outcome valid. Okay, now in exam questions, when you're given a table or a graph, you'll always find the IV on the left side of the table. So the table of results will always show you the independent variable on the left. And the dependent variable will always be on the right of the table. Any control variables, you're probably going to have to think of those for yourself. So you need to think about what needs to be kept the same. Okay, so let's see how that looks on tables. Okay, so mobile phone use in hours per day, sperm count in millions of sperm cells per centimeter cubed of semen. Okay, so what's being changed here is we've got probably different groups of people. Some of them are not using phones at all, some of them just very little, medium amount, and quite a lot. So independent variable, different groups of people using the phone for different amounts of time. And the dependent variable, they want to see, is that actually affecting sperm count? In this case, looks like It does. So bad news for anyone trying to conceive a baby who's addicted to Candy Crush. Now, pause here for a second, pause the video for a second, see if you can figure out what variable is which. Hopefully you remembered the independent variable should be coming up on the left. A little spoiler there, I left the arrow on the presentation, so that might have given it away. So the color here and the temperature would then be the dependent variable. So we've got temperature after 20 minutes, temperature fall. So it looks like something has happened here in this practical where we had a starting temperature, and that was all continuous for each condition. So that was, sorry, not continuous, consistent for each of these variables, different colors, and temperature at the end. Notice that they made a measurement here. That was the direct measurement, but the total outcome, what they were really interested in was how much did the temperature fall. So that's really what we would label our dependent variable. Okay, so that's for tables. Now for graphs, for a graph, they'll always show you that on the bottom of the graph is the independent variable. So that's the thing that I'm going to be changing. So along your x-axis, that's going to be the thing that changes in like a predictable pattern or in a pattern where I'm responsible for that. And then the outcome of the experiment is going to go on your y-axis. So, oops. Oh, let's take a look at that there. So for this graph here, the independent variable is the thing that changed, and the dependent variable is the measured outcome. So from this graph here, it looks like we've done an investigation into wind turbines with a varying number of blades from 1 through 6. Okay, 0 blades, doubtful we tested that. And the dependent variable then would be measuring how much potential difference can be produced in volts, so the output voltage, and seeing if there's any relationship between those two. And from this, it looks like not directly proportional. It looks like it hits a limit. And so this one gave us a curved line of best fit. But independent variable is on the bottom of the graph, and the dependent variable is on the y-axis, just as it showed you here. Okay, and again, the graph won't really show you the control variables, but you could think about a practical like this. You would need to make sure that the wind conditions, for example, were kept the same. So if you were using a fan, it would need to be on at the same power, or else your wind turbine wouldn't be a fair test. Okay, here's another one. For a bar chart, you've got different materials, and you've got time taken in seconds. Now, we don't know all about this practical just from looking at that, but we do know that the independent variable is on the x-axis. So even though this is a bar chart, and those are categoric variables, so we're testing different materials, therefore we need a bar chart. There's no connection between concrete and copper and iron, so we couldn't plot that as a line graph. But you still put that independent variable on the x-axis with the time taken to do whatever it was, whether it was smash or dissolve or whatever the time taken was, that's our result. Okay, pause and think here. What would be the independent dependent variable there? Same like before, year is your independent variable. Dependent variable here is how much percentage of electricity is generated. Looks like over time, over the years, more and more of our electricity is generated from renewables. Only up until 2005 though. Okay, quick quiz now. Oh, this isn't working. That's not working. Yeah, these were supposed to come up like animations. Okay, I'll skip those ones and we'll do these ones. Okay, so as I put this up here, and those animations should hopefully pop up for all the other slides. It was working before, so sorry about that, guys. Okay, so take a look at each of these as I put it up on the screen and have a think about it. Now, I've already given it away. So what is the independent variable? What is the dependent variable? Suggest some controls. Looks like we've got mass of water on the left. That's going to be our independent variable. We're timing them to boil. And that is not our final dependent variable. That is what we're going to measure directly. We're going to measure that directly 3 times and calculate a mean. But then we're working out the mass times the change in temperature in kilogram degrees Celsius so that we can work out the energy supplied. So usually to the far right is going to be your dependent variable, but you kind of got to think it through. So in this case, we need to make sure that some things are kept the same, and it looks like as the mass of water increases, the energy supplied in kilojoules is also increasing. So that would be our relationship. But the control variable here would probably be something like the starting temperature of your water, and also the rate of energy transfer from the device. So if you're using a Bunsen burner, you need to be on the same flame or something along those lines. Take a look at this one. Okay, same as before, extension is what I'm changing. The force applied is my dependent variable. We don't have enough information about this practical to understand it too clearly, but we know that on the left is going to be the independent variable. We're using different liquids, and it's something to do with forces. So it's measuring how much force is required to do something in that practical. So we probably can't identify any control variables from that because there's not enough to really understand the practical just from those results. This is a reaction time test. We've got different people. We're directly measuring the reaction times, and then we're working out the mean. So really, our dependent variable is the mean reaction time, and what I'm changing is a different student each time. Those will be categoric variables, boy 1, boy 2, girl 1, girl 2. Those are completely different people. If we were to plot this, it would be a bar chart because they're different people. And for control variables, you'd want to make sure there's no distractions. They're being prompted to respond in exactly the same way, and the equipment that they're using to respond with is exactly the same. So if it's a meter ruler drop, make sure it's the same ruler, make sure it's the same person dropping it, things like that. What if they change the layout of the table? Can you still cope with that? Can you still make that work and figure it out? Okay, we've got temperature in degrees Celsius and the mass of ammonium nitrate. Well, even if they flip things around, you can have a think about that even without understanding what the practical is about. We've got a chemistry question here, something about dissolving this chemical in water. Ammonium nitrate is a salt. It looks like there's varying amounts of that, varying masses, I should say, that will dissolve at different temperatures. Now, looking at the numbers, you can see one of them goes up steadily. That's a huge clue. That's your independent variable. The temperature increasing at 20-degree intervals tells you I'm in control of that, I'm changing that, so therefore that's my independent variable, and I'm measuring the mass of ammonium nitrate that dissolves. Now, given to you as information in the text, you can still identify from this. So, investigating how does the concentration of acid affect the rate of reaction? That word affects there always comes before your dependent variable. So we're looking at how IV affects dV. Student investigates how does concentration affect the rate of reaction. And there's the method. You should be familiar with that from your chemistry. Magnesium ribbon, hydrochloric acid, collect the volume of gas at 10-second intervals. Here, the rate of gas production is the rate of reaction. And repeating it with different concentrations. So control variable there, you'd need to keep the volume of hydrochloric acid the same, and even better if you could, rather than measuring out a 3-centimeter piece of magnesium ribbon, measure out a specific mass. We've got another chemistry question here. Investigating temperature change when zinc reacts with copper sulfate. Different concentration of copper sulfate for each experiment. What's the independent variable? What's the dependent variable? The clue here is the word different. The word different is always associated with your independent variable. Different concentration of copper sulfate, and what we're investigating, that's our dependent variable. So they didn't use the word affects here, so that wasn't the clue. The control variables would need to be the mass of the zinc and the volume of copper sulfate as well. Now for a physics one, this one is quite tricky, so have a think. Okay, we've got that word investigating, so that tells us that's our dependent variable, the strength of electromagnets. And they're investigating that by seeing how many paper clips they can attach. Hopefully that's familiar with you. Now, this is tricky because, again, they are changing two things here. That's a bit of a confusing variable. So they've not controlled every variable. They've set up two independent variables here. You may not have spotted it. The most obvious one is the number of turns. So they've changed the number of turns of the coil. That's a solenoid or an electromagnet. So more turns should give you a stronger electromagnetic force and therefore a stronger electromagnet. Hence, there are more paper clips attached there. However, they are also investigating the direction of the current. So if they're using a direct current, for instance, they could just be swapping the battery direction, just swap it around, go the other way, and they're seeing if that has any effect. You'll notice the arrow for the current going in opposite directions there. But other things they should control: make sure the coils are equally spaced, use the same nail, use the same size paper clips, have the same person putting them on, make sure that you're starting with fresh paper clips each time, things like that. Okay, so that's it for variables, and then it comes to, well, once you have the variables, if it's you plotting the graphs, what actually needs to happen? You do need to follow the same rules with your graphs. I'll just go back to that there and show you to make sure that your dependent variable is going on the y-axis and your independent variable is going on the x-axis. So make sure that you're following that same rule for any graphs that you draw. But a lot of people are confused about whether it should be a line graph or a bar chart. So this is what I hinted at earlier. For this practical here, this is a physics practical, angle of incidence and angle of refraction. We'd be changing the angle of incidence and measuring the angle of refraction, so that follows our pattern. Now, all of this is continuous data, meaning any of the results could have fallen anywhere on those values on that scale. So you didn't have to do 10 degrees, you could have done 9 degrees or 8 degrees. Any of those measurements would have worked. To contrast that, this is the one we did earlier, this would be a bar chart because it would be a categoric variable. And also shown at the bottom there, we've got different categories of fruits and vegetables, so they have to go in different pots, hence you would be using bars going up to slightly different heights. Okay? So for this example here, a line graph is not a suitable way of showing results because those are all completely different materials. So different metals could not go along an x-axis showing a line graph. And similarly here, there's no connection between those different materials, so we have to put them into separate bars. Lines of best fit is somewhere that students often lose marks. So here are some good rules for lines of best fit. Number one, it does not have to go through the origin. It only goes through that if it really fits the data. And I'll show you some examples. Number two, do not use a straight line unless your data shows you a straight line. So if it's a straight line, you have to use a ruler. You should always follow the points, but you do not go dot to dot, and you do not include anomalies in lines of best fit. If it is a curve, it should be drawn freehand, but not sketchy. Okay, so on the left, we've got a bad example ranging up from 0 to 5 on the y-axis. You can plot that exact same data without including all that data down to 0, and you get a much better spread. It's much easier to see the relationship being shown there. You'll also notice that because it's a straight line, we're using a ruler, we're not joining dot to dot. Okay, but our axis does not have to start at 0. Now this one doesn't have any data, But if you look carefully at the numbers, there's a problem on the x-axis for the one on the left. Did you spot it? It's right there. Okay, 0, 5, 10, 15, 25. What happened to 20? Okay, you got to go up by the same amount each time. This is a bad example. They're forcing the line of best fit to go through that origin point, even though they haven't put 0 as the origin. They're forcing it to go down there. Much better if you just go a little bit higher on your graph. Okay, it should follow the points, not force through the origin. And that's it, guys. So I really hope that that was useful for you. Just close that down. And hopefully you have understood some more about variables today. If you get to use this on some future exams, then you're going to pick up some more marks. Thanks very much for watching, and have a great day.